characteristics of both the sine and the cosine graph. Now, the first thing I want to point out is that on each graph, there are 5 key points. So for sine, you're going to notice that it starts at 0, 0. That's because the sine of 0 is 0. And then at pi over 2, sine is 1. At pi, sine is 0 again. At 3/2 pi, or 3 pi over 2, sine is -1. And then at 2 pi, sine is 0 again. These are generally the 5 points I like for students to go ahead and know so that they can quickly put them on the graph. And then if you connect, you'll notice that we get this nice, what we call a sinusoidal wave. And this represents one cycle or one period of the graph. Because what would happen after this? Think about after the first rotation on the unit circle, you would go to a second rotation. And so these values would repeat. If we were going to continue the graph, it would continue doing something like that. Now let's look at the cosine graph. So we need those 5 key points again. And this time, cosine of 0 is 1. So it starts with a point here on the y-axis at 0, 1. Then pi over 2, cosine of pi over 2 is 0. Cosine of pi, -1. Cosine of 3/2 pi, or 3 pi over 2 is 0 again. And then cosine of 2 pi is again 1. And you can go ahead and connect these graphs to get the cosine function. Now remember, this is just one cycle. This is one time around the circle. What would happen if we continued the graph? It would repeat, right? In both directions. Think about it. It would look something like this. Could do the same over there. Now look at both graphs. Notice they're the same shape. Really. One is just shifted over from the other. Okay? So now let's point out some other key factors that I like students to know with regard to both of these graphs. For the sine graph, remember, we're only looking at one period or one cycle through the unit circle. But the real graph would continue in both directions. So my domain, because it would continue in both directions, would be all real numbers. If you like to write that in interval notation, then I want you to consider writing it as -infinity to +infinity. Now think about the range. Look at your y values. Your y values have a low at -1 and a high with a y value of 1. So your range is between -1 and 1. And again, you can write that as an interval if you write it as bracket -1 to 1. Meaning the sine value is not going to get above 1, not going to get bigger than 1, and it's also not going to get smaller than 1. All right, couple more pieces of information I like for you to know, and that is the period. Now I used that word earlier to talk about one cycle of the graph. So another way to think of this is how long is it before you repeat the graph? How long is it on the x-axis before you repeat the graph? In this case, it's one time around the circle, and that would be 2 pi. So the sine graph has a period of 2 pi. It travels 2 pi on the graph before the values begin to repeat, before the wave repeats. All right, last piece for you, and that is the symmetry of the sine graph. Now, the symmetry of the sine graph, think about if you were looking at the whole graph. Think about the graph over here. You would have origin symmetry because you could take this graph and spin it 180 degrees and you would get the same graph. So the sine graph has origin symmetry, and I'm going to put in parentheses. That's because it's an odd function. Not unusual odd, but odd versus even function. So these are the key things I like students to know about the sine graph. They've got their 5 key points, their domain, their range, their period, and their symmetry. Now let's look at the same information for the cosine graph. Remember, we said the sine and the cosine graph are very similar. One's just shifted over from the other. So I'm anticipating that some of this information is going to be similar. So domain, you want to think about the entire graph if I drew it, all of it. And that would mean that I would have all real numbers as my domain again. Remember, you can write that with interval notation, negative infinity to positive infinity. Now your range, think about your high and your low y values. You've got a low value of -1 and you got a high value of +1. So I'm going to write that range again, the same as the sine, -1 to 1. Okay, pretty similar so far. Period. How far does it travel before the wave repeats? Yep, it's just like sine. It takes 2 pi before it begins to repeat. All right, now last piece, look at the graph. What kind of symmetry does it have? You're right, it's a y-axis symmetry for cosine. And that is because it's an even function. So again, here's all your pieces of information you need to know about these two very important trig graphs. You want to know your 5 points, your domain, your range, your period, how long it takes before the graph repeats, and of course then your symmetry. Okay, now let's turn our attention to the tangent graph. You remember that sine and cosine were very similar, had some similar points, similar domains and ranges. Well, tangent's not going to be anything like that, because we know that tangent is the sine over the cosine, or we also know that tangent is the opposite over the adjacent. The problem here is that we have some undefined values of tangent. And so I'm going to draw those as asymptotes on this graph. And those happen at the odd multiples of pi over 2. Let me show you what I mean. At 1 pi over 2, there is an asymptote. At 2 pi over 2, there's not. It's an even multiple of pi over 2. At 3 pi over 2, that's an odd multiple again, there's an asymptote. Okay? And that plays into our domain. So I'm going to go ahead and write our domain here. Instead of saying all real numbers, because it's not all real numbers, I'm going to say that x cannot equal pi over 2, because I've got an asymptote there, 3 pi over 2, and I'm going to do a dot, 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 because the pattern would continue. At 5 pi over 2, it doesn't exist. 7 pi over 2, it doesn't exist either. So now let's look at what does the graph do between the asymptotes. So at the even multiples of pi over 2, you have an intercept. So you've got an x-intercept at 0, an x-intercept at pi, an x-intercept at 2 pi. Again, it would continue, an x-intercept at 3 pi, and so forth. And the graph behaves much like an x-cubed graph between these asymptotes. So it's going to come up, do a little snake action. And I like my students to know that. They don't have to plot points in between. I like them to hit the x-axis in the right spot. I like the shape to be correct. And so I'm going to draw the first half of that little snake action, and I'm going to draw the little second half of that snake action there. You can remember, the graph's going to continue and repeat. I'm just drawing a section of the graph. So looking at your graph now, what about the range? Yeah, these y values go all the way to negative infinity and they go all the way to positive infinity. So my range here is all real numbers. And remember, we can write that as negative infinity to positive infinity if we're using interval notation. What about the period? So how long does it take for this graph to repeat? Well, one cycle of the graph is between 1/2 pi and 3/2 pi. So that takes a distance of pi. So the period of the tangent graph is just pi. That makes it a little different than sine and cosine. Finally, symmetry. what kind of symmetry do you see here in the tangent graph? You're right, it's origin symmetry. Because I can take this graph and rotate it 180 degrees, and I'm going to get the same graph. And that is because tangent is an odd function. So we've covered sine and cosine, all the important details of their graph, their symmetries, domain and ranges, and their period, and as well as the tangent. So take some time, make sure you've got good notes for this, because when you do transformations of these graphs, knowing the key parts is going to be very important.